Let's talk about how to solve a quadratic inequality. So the solution to a quadratic inequality is related to the x values that are covered by the shading along the x-axis. So it's related to the x values covered by the shading along the x-axis. Which means the easiest way to solve a quadratic inequality is to use a graph. Okay, now our graphs are not going to be super accurate like the one that you see here, but we are going to be making sketches of graphs to help us with this because we're pretty proficient with deciding if it's a solid line or a dashed line parabola and if it's shaded above or shaded below. All right, so what you see down here is we have the graph of y is greater than or equal to x squared minus 9. So pretend that this 0 is really a y here, okay? So thinking about that, this is like saying y is greater than or equal to the parabola. Okay. So that's why it's shaded above the vertex or inside, all right? When we go through and we try to solve this, this is what we're focusing on. Now the x-axis is right here, okay? So we want to know, well, what part was shaded twice? The part that's shaded twice goes from right here to right here. This is the part that got shaded twice. These are my solutions. So I need to identify, well, what are those x values? All right, so I'm going to draw a little number line right here. And this is going from -3 to 3 with a closed circle, and connecting the two dots together. Okay. So that's like saying that x is between -3 and 3. As an interval, we're starting at -3 and ending at +3, inclusive of those two numbers because it was an equal to in the inequality or a solid line on the graph or closed circles on the number line, okay? So that's the solution to x squared minus 9 is less than or equal to 0. So any number between -3 and +3 will work, inclusive of the -3 and +3. Now, how would we solve, or rather, how would the solution change if the problem was switched so that, take a look here, the inequality symbol here and the inequality symbol here are reversed? So think for a moment, if the inequality symbol flips around, what does that change about the picture? So let's re-sketch this picture real quick. So here's -3, here's +3. We've got a solid line parabola opening up through there. Because the inequality is facing the other way, that means the shading is reversed. So now all the shading would be out here instead. So now where would we have our solutions? Well, again, if we take a look at the actual x-axis, we're looking at this segment right here. We want to know, where did we shade twice? So the solution set would now fall from here to the right and here to the left. If we think about that as a number line, the x-intercepts are at -3 and +3. We have closed circles. We're going to the left of -3 and to the right of +3. Now remember, the left of a number line is negative infinity. The right of a number line is positive infinity. So when we go to write those inequalities, we would say x is less than or equal to -3 or x is greater than or equal to 3. With intervals, I'm going from negative infinity up to -3. I can include the -3 but not the infinity. I've got a separate interval from 3 to positive infinity. I cannot include infinity, but I can include 3. So that would be the solution to x squared minus 9 is greater than or equal to 0.